Okay, guys, so today we're going to work on Unit 1, Lesson 5, Midpoint and Distance in the Coordinate Plane. Midpoint is something you should already know. On a number line, you've been doing midpoint for a long time. We did it earlier in this section too. Simply, all you do is you take the first number and the second number, and you divide by 2. And so if you were to ask me to find the midpoint of DE, which is what we did earlier on in Lesson 2, I would just say, okay, well, this is at 7, and this is at 11. 7 plus 11 divided by 2 equals 9. So the midpoint of DE is 9. You can do 2 through 4, and I'll check those in class to make sure that you did them. And we're going to use this skill. So if we have a coordinate plane, which is what this is called right here, coordinate plane, it's the same formula, except for instead of x plus x divided by 2 and being done, we also have to do y plus y divided by 2. And so that tells us the midpoint. And so it's really simple. If I'm doing number 1 here, I'm taking 3 plus 13 and dividing it by 2, and I'm taking 6 plus 2 and dividing it by 2. I'm doing both of those. And so my midpoint of line segment AB would be 8, 4. Okay? Now, you can get decimals and fractions and whatever. So when you do 2 and 3 on your own, this is another thing I want you to do real quick on your own, you will get decimals, 0.5, 0.75, they're okay. You just understand that sometimes you will get decimals, okay? But anyway, this is just the simplest way to teach midpoint. Is take something you already know and just double it because you have 2 coordinates, and then you go from there. Just don't forget that x's always come first. So you're going to add those 2 together, and then you're going to add the y's together. They always come second. Okay? And make sure you keep your negatives straight when you add. You'll be fine. When the midpoint gets hard is what we see here. So if I tell you the midpoint and I give you the endpoint, there's really a couple different ways to do it, but this is the way I like to do it the most. I like to draw a number line, and I like to envision that if this is the midpoint for -9, and this is A, and this is B, and you tell me that A is at -3, -9. Well, I could sit there and tell you the formula to how to handle the midpoint, and I'll show it to you. It's m equals x plus x divided by 2, and m equals y plus y divided by 2. And you can do a bunch of substitution and solve, and if you want me to show you that, I certainly will do that. But I like this way a lot better. How far did it take to get from -3 to 4? Always positive if you can handle it, if you can do it that way. Well, to go from -3 to +4, I had to add 7. How far did it take to get from -9 to -9? Well, to get from -9 to -9 is 0. So when I'm trying to find B, I'm going to follow that same rule here. I'm going to add 7, and I'm going to do nothing on the bottom. So that when I add 7, I get 11 and -9 when I add 0. And so the coordinates of B is 11, -9. Okay? I'll go over this again tomorrow in class, but we want you to go ahead and take a look at number 2. If you want to give that a shot, use the number line method. I think that'll be the best way. Again, you're given the midpoint and one end. And so, again, you may be adding or subtracting, depending on whatever the rule is to get from the midpoint to your endpoint. The second topic we're going to be talking about is distance. And distance on a coordinate plane is given by a formula where distance is equal to the square root of y minus y squared added to x minus x squared. Believe it or not, this is just the reverse of the Pythagorean Theorem, which you guys should remember the Pythagorean Theorem as a squared plus b squared equals c squared. Well, if you can imagine that the x and the y are your a's and your b's, and we're going to be solving for c, the way you would undo that is to take the square root of it. And so that's essentially what we're doing here. So that's why you have two choices. So like when I look at number 1, using this formula, I just substitute. Well, 4 minus negative 1 squared plus negative 2 minus 3 squared. Well, 4 minus negative 1 is 5, so it's 5 squared here. Negative 2 minus negative 3 squared is negative 5 squared there. Well, 5 squared is 25, and negative 5 squared is also 25. And so my answer, and by the way, this is all under the square root sign the whole way. My answer is the square root of 50. This also could be 7.07. Okay? Now, we're going to get into some other stuff about how to reduce these later. But first off, I just want to show you Pythagorean Theorem. It's just another way, and then we're going to leave number 2 for us to do in class. So for the Pythagorean Theorem, you have to plot the 2 points. So I have negative 2, 4, and 3, negative 1. And you create a line. When you create that line, that automatically becomes the hypotenuse of a right triangle. And so since you have a right triangle, you can use the Pythagorean Theorem. If this side is 5, and this side is also 5, this is the side I'm looking for. So 5 squared plus 5 squared is equal to x squared. So again, 50 is equal to x squared. Because 25 plus 25 is 50, and that's equal to x squared. And then when I take the square root, I get x is equal to the square root of 50. Or 7.07, or 5 times the square root of 2, which is what we'll talk about tomorrow in class. So again, distance formula, it's not not a big secret. It's a formula you have to memorize. If you're not going to memorize distance formula, you have to be able to use Pythagorean Theorem. Both methods work. So we will discuss these further in depth in class. Again, remember the key topics today were midpoint and a coordinate plane, and how we use what we know about midpoint on a number line to do that. How we use the number line to help us find an endpoint when we know one and the midpoint. And then finally, the distance formula and how it relates to the Pythagorean Theorem. So be ready to talk about these topics tomorrow. Be ready to share with me and with your classmates.